Thank you so much for watching this online video tutorial. Please like, comment and share the video. And please don't forget to subscribe to our YouTube channel at Good, Better, Best Online Videos for more content.
Good day and thank you for joining us. So in today's lesson what we'll be looking at is the function of the hyperbola. Cool, so in this lesson we'll be mainly focusing on plotting it, but before we get into that, let's just get ourselves introduced to this new type of function that we are not used to seeing. So the standard formula for hyperbola is going to be as follows. It's y is equal to a over x plus q. So let's just get into breaking down what all of these different things mean in our equation. You can see a q over here. We see this quite often. We see this in our parabola, and what that is in our parabola tells us our vertical shift. Cool. So it's going to be our vertical shift indicator basically. But what it is also going to be is our horizontal asymptote. Okay, cool. So what we need to get to grips with our hyperbola is the fact that there are two asymptotes. Oops. So there are two asymptotes. One of them being the q, which I just identified. So our q is one of our asymptotes, right? And when we draw this on our graph, it will be represented by a y value, okay? Because obviously being a horizontal asymptote, it corresponds with a y value, right? And then the other asymptote, while we're in grade 10, it will remain as x is equal to 0. And remember, x is equal to 0 is our y-axis. Cool. So one of our asymptotes will be our y-axis, which is that x is equal to 0. And then our horizontal asymptote will be q, which is in our equation, which will represent on the graph as y. But also remember that if there is no q value or q is equal to 0, that our horizontal asymptote is our x-axis in that case. Cool. So now that we've covered that, we can have a look at one of the other things over here which we can see, which is a, which we see in all of our functions or most of them as well. So what is a? A is going to tell us the positioning of our hyperbola on our graph. So hyperbola is a bit unique where it has two different parts to it, okay? So I'm going to show you how that looks right now. We have, say if a is positive, cool, so we get given the equation and a is positive in the equation. Our hyperbola is represented on the graph as these. Cool, so you can see that there are two different parts to the hyperbola. Don't be intimidated by it, it's quite simple to plot and we will get to that eventually. But when a is positive, we are in this quadrant over here. We'll call this quadrant 2 and this quadrant 3. So it's in quadrant 2 and 3. And when a is negative, then we are in quadrant 1 and 4. So you can see it's just complete polar opposites, but also the two parts of the hyperbola will always be opposite one another, right? So we can see when a is positive, we're in quadrant 2 and 3, and when a is negative, we're in quadrant 1 and 4. So just to keep that into your mind, just to show you, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So if we can have a look now at our first example over here, we have f of x is equal to minus 6 over x. Cool, so the first thing I want to take a note of is that there's a negative here. What I want you to always do with this negative is to apply it to that numerator over there, specifically when we are busy with hyperbola. It's just going to help us identify what our a value is, and in this case, if we move this negative up, our a value is going to be negative. Cool, so our a value is negative. So therefore we know that we will be in the, if we look up here, that is in the first and fourth quadrant. So then we can just indicate to them that we know that a is negative and that we are in the first and fourth quadrant. Next, what we need to realize is that also there is no q value included here. Cool, so there is no q value here on the end. So if there is no q value, we know that q is then basically equal to 0, which means that our horizontal asymptote is going to be the x-axis, right? So we can just say here that q is equal to 0, and so we know that our horizontal asymptote is equal to 0, basically y is equal to 0, which they all know is the x-axis. Moving on, what we need to do now, once we've identified our asymptotes, is to find one point to plot on this graph. So to find that point, we'll be using the table method. So what we need to do is basically plug in x values into our equation here, and we find that with hyperbola it's best in this table to use factors of our a value. And so obviously our a value is 6, so we use the negative and positive factors, right? So we'll just find those factors. Obviously we know it is 1, 3 and 6, but we'll use negative and positive values. So what I mean is we'll have minus 6 over here, minus 3 here, and minus 1. So the reason why we don't use 0 in any case when we're busy with this table method is because remember, where x is equal to 0, that is our y-axis, and remember that is one of our asymptotes, and we know that the graph will not touch the y-axis, so that's why we will never use x is equal to 0 in our table method. So now that we've reached -1, we can go now +1, +3 and +6, and all that's left for us to do now is to fill in these corresponding values. And if we go through it, it'll be -1, -2 and -6, and then you'll see what happens here on the other side is it's just the polar opposite. It's 6, 2 and 1. Cool, but this isn't the same in every case. This is only because the graph is not shifted vertically, right? When the graph is shifted vertically, these values will vary here by the y values. Cool, so it's just important to go through each one. Now what's down to us to do is to plot this, right? So if we're going to go and plot in our Cartesian plane, so obviously my Cartesian plane isn't going to be completely to scale, but we'll work with what we got here going on. So we got -6 and -1 to plot first, right? So let's go -6 and -1. -6 on the x-axis, 1, 2, 3, 4, 5, 6 right over here, and -1. Cool. So we know that we are following probably the correct path, because remember we identified where our graph will be represented, and it will be in the. So now what we're going to go ahead and do is use the table. So what's happening is we are substituting this into the equation. So we go -6 divided by -6 will give me +1, -6 divided by -3 will give me +2, -6 divided by -1 will give me +6. And then moving on, -6 divided by 1 gives me -6, -3 divided by +3 gives me -2, and then -6 divided by +6 will give me -1. Cool, so you can see that this goes, the numbers are directly opposite to one another, but this isn't always going to be the case. It's only like this where we're going 1 to 6, -6, -2, -1, because we do not have a vertical shift. In the case that there's a vertical shift, there won't necessarily be this type of pattern to the y values, so it's always good to go through all of them. So now we can move over to plotting them. Obviously we know our asymptotes is the x and y axis. In this case it's always going to be the y axis, but because we didn't have a horizontal or a vertical shift, the horizontal asymptote is going to be the x axis. So now we go ahead and plot our points. We have -6 and 1, so -6 being all the way over here and +1 being here. Then we have -3 and +2, that's over here and over here. And then we have -1 and +6, so -1, +6 is all the way up over here. And then we can just go through all of these points. Then what's important for us to do after that is to identify the points that we've just plotted, which is going to be -6 and 1. This over here is -3 and 2. And then we have -1 and 6. Moving on now, we can plot the right side. We have 1 and -6, so 1, -6 all the way over here. Then we have 3 and -2, 3, -2 is over here. And then 6 and -1, 6, -1 just over there. And once again we'll just go through all of those points, staying away from the axes, because we know that that is our asymptotes. And remember, we do not touch or cross over those asymptotes. And once again we'll just plot all of these points that we have here. We have 1 and -6, we have 3 and -2, and then we lastly have 6 and -1. So just like that, we've plotted our hyperbola. Just know though, because remember at the start of this example I did say that we only need to find one of these points, and that's all you really need to do. So in the case of that, you could have done the table method and just choose any one of these points. We choose, let's say, -3 and +2. So we plot -3 and +2, and all we need to do is draw a hyperbola that goes through that point but also adheres to the asymptotes, right? So that once we draw that, all we need to do afterwards is draw this one. We can just rough sketch in this other one actually, and I'll show you in the next example basically how that works. So moving on, here in our next example we have f of x is equal to 6 over x plus 2. So once again we're just going to go through identifying what our different things are. So like for instance, we can see that a is a positive number, and so we know that we are going to be sitting in the second and third quadrant of the Cartesian plane. And then also we know that now we actually have a q value. So q is equal to 2. Therefore my horizontal asymptote, obviously we don't have to write it out in full to take too much time, so horizontal asymptote is y is equal to 2, and that's how we'll represent it on the graph. Moving on from here, what we can do is find just one point to plot, and that one point to plot, because now we know that we have a vertical shift, or yes, a vertical shift, we know that now that we do have a asymptote that is greater than 0 for that horizontal asymptote, right? Which means we do cross over the x-axis, so we have an x-intercept. So what we can do is work out the x-intercept, and that will give us just our one point that we need to plot. So remember, if we're trying to work out the x-intercept, we need to make y equal 0. Cool, so let's go ahead and do that. So we have our equation here. Obviously we know f of x is y, so we just say the equation is 0 is equal to 6 over x plus 2. 2 goes over, it becomes -2 is equal to 6 over x. And so then once we need to get x away from the 6 over here, so we're going to times by x, or we do to one side, we do to the other side. So what happens is we have -2x here on this side is equal to 6, and then to get x by itself we divide by -2 on both sides, and so we get x is equal to -3. And remember, because it is a plotting point, we need to write here the coordinate is -3, and obviously we know y is 0 because it's an x-intercept. And so now what we can do is draw our Cartesian plane. So now that we have our Cartesian plane, the first thing we always want to do is attend to our asymptotes, right? We already know that the y-axis is one of our asymptotes, but all we need to do is draw in that second asymptote, which we know is the q value, which was 2, right? And we saw that our horizontal asymptote is y is equal to 2. And so y is equal to 2 is right over here. So we can just draw our dashed line as our asymptote. We'll indicate on either side y is equal to 2, and that they'll know that's our horizontal asymptote. Right? And so we know obviously that our drawings will adhere to these asymptotes, so we'll not cross over them. So we don't cross over the y-axis, and we don't cross over this asymptote of y is equal to 2. And then what we can do is plot this one other point that we found, and that's all we really need is that one other point, which is -3 and 0. So let me just grab another color here. That's -3 and 0. -3 on the x-axis is over here. So it's -3 and 0. Right, and all we need to do now is sketch a graph that crosses through that point and adheres to the asymptotes, right? So we'll adhere to the asymptote, then we'll cross over that point, because obviously we know that the graph does pass through that point, and we know that we are in the third quadrant, and this is how the hyperbola moves in the third quadrant, right? So once we got that, we'll just indicate here that this is -3, so they know, okay, that's our x-intercept. And then because you're only in that one point, what you do for the other side of your hyperbola is just a free sketch. That's all it is really. Unless there are specific instructions asking you to indicate the points for both parts of your hyperbola, or if the mark allocation is a bit high, you can refer back to this or back to the previous example where you can see we did each point here on the graph, and you can indicate each one of them. But as far as hyperbolas go, this isn't very necessary to do. All we need is our asymptotes and 1 point to plot, and then we can free sketch that other part of our graph. Cool. You can also find this point by doing the table method, right? Because obviously we know now that we do have a vertical shift. We know that we can have I'll just remove like this last 10-15 seconds that I just fumbled my words, but okay. I'm going to continue now. We can just use that table method, plug in any value, and then we'll get that corresponding y value, of course, and then just plot that 1 point in this graph and go with that. And so just to solidify our plotting methods, we're just going to do one more example for you guys quickly. And so for our last example, we have f of x is equal to 4 over x minus 2. So we'll identify that we have a that is positive. And so we know that our graph will lie in the second and third quadrant. We have a q that is equal to minus 2. And so we know that our horizontal asymptote is y is equal to minus 2. And then all we need to do from this point, remember, we know now where the graph is going to be plotted. We also know what our horizontal asymptote is. So now we just need to find one other point, and because we have a vertical shift, we can find an x-intercept. And so we'll go our x-intercept. So we let y equal 0. So we have 0 is equal to 4 over x minus 2. Once we do that, 2 comes over, becomes positive 2, so we have to 4 over x on this side, times by x on both sides, so we get 2x is equal to 4. And then we divide by 2 to get x by itself, to get x is equal to 2. And just like that, we have our x-intercept of 2 and 0, always indicating what that intercept is, right, in its coordinate form. So now we'll get our Cartesian plane out. So now with our Cartesian plane, we can first input our asymptote, which we found is y is minus 2. So minus 2 is over here. So we'll just throw out here, like that. So we'll say y is equal to minus 2. So then now that is our horizontal asymptote. Just throw it going out like this. Obviously you use a ruler and you'll go along with making dashed lines. I'm just doing it freehand right now. Then what we're going to do is we're going to take our x-intercept, which we found is 2 and 0, which is over here. Indicate quickly that this is going to be our 2 and 0. We can just indicate that it is 2, just so that I know that that is our x-intercept. And then all we need to do is adhere to the asymptotes and draw our graph passing through those points, like this. And you can try and get close to the asymptotes as well. And then remember, the other side of the hyperbola we can just draw freehand as long as we are adhering to the asymptotes, and unless they keep asking us to specifically identify a point on this other part of the hyperbola, we don't really have to. And just like that, guys, it is going to conclude our lesson on plotting hyperbolas. I hope that this has been helpful to you guys to understand how to plot it. Just always important things to note. Remember, our q is our vertical shift and our horizontal asymptote, and our a will tell us which quadrants of the graph we're going to be in. Don't forget, we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. If A is positive, we will be in quadrant 2 and quadrant 3, and if A is negative, we're in quadrant 1 and quadrant 4. Sorry, I meant to put in negative. There we go, quadrant 1 and quadrant 4. So guys, just like that, it is as easy as that, and once we get those points down, we have to find one point to plot on our graph, which we can use using the table method. And remember, in the table method, those x values preferably need to be factors of our a value. So if our a value is 4, our factors is 1, 2, and 4. If it's 6, it's 1, 3, and 6, and so on. And we will never use 0 as one of those x values, because remember, where x is 0, that is our y-axis, which is our vertical asymptote. Well, thanks for joining me today, guys. I hope that you have a good one.